Let's do monohybrid cross. As we have already seen, for parents, plants with opposite traits are chosen. The phenotype of the plant is tall plant and the other one is dwarf plant. Okay, these are taken as parent. This is the symbol of parents. Now we'll write the genotype. This is the physical feature. Phenotype. Genotype is and small t. Okay. Now when they are crossed, the gametes will fertilize and F1 generation will be produced. So before fertilization, production of gametes are important. So now we'll form the gametes. We know during gamete formation, diploid by meiosis converts into haploid gametes. So these two alleles get separated. One goes in one gamete, other goes in other. Same with this parent. During gamete formation, haploid condition comes. Now when these gametes are crossed, they will fuse. One gamete from one parent will fuse with the one gamete of other parent. So this comes in F1 generation. The result will be the F1 progeny. This gamete can fuse with this, or this gamete can also fuse with this one. There is a chance, we are not sure which gamete from this parent will get the chance to fuse with either of these. Okay, so we have to write all the probabilities, all the chances. Same, this gamete can fuse with this, or this gamete can fuse with this. Capital T, from here it will come small t. Capital T, small t. So in all the cases, what we see, the genotype of the progeny is capital T and a small t. One dominant allele and one recessive allele. And phenotype we have already seen. All the result plants are tall. All tall. Okay. Now in F2 generation, to get F2 generation, these two or any of them, two are taken as parents. They are crossed. So these two are self-crossed. Now they are like parent. Gametes formation. Alleles will get separated. These are the gametes. And then F2. In F2 generation, what will happen? This gamete can fuse with this gamete, or this gamete can fuse with this one. So capital T from this side and small t from the other parent. Okay. Now this gamete can fuse with this gamete. See, we have to write the capital first. It may come from either of the parent. यहाँ से आए या यहाँ से आए. Capital पहले लिखेंगे. Okay. This gamete can fuse with this gamete. So small t and small t. So we can see capital D, homozygous genotype, heterozygous genotype, and homozygous. This is dominating, this is recessive. What is the phenotype? Tall, 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 dwarf. Right. So 1, 2, 3. How many tall plants? 3. And dwarf 1. So phenotypic ratio is 3:1. This ratio is phenotypic ratio of which generation? F2. Okay, let's do it with another example. We got to know, we have to take the parents and write their genotype and phenotype both, then gamete, then F1, then self crossing, and then F2, and the ratio of F2. Okay, now the second example we have already taken was green pods and yellow pod plants. So parents are, phenotype is there clear, green pod plants, and the other parent have yellow pod plants. Genotype, capital G, small g, small g. Okay, now gametes. And there small g, small g. Now F1 generation. This allele from the parent and there this one. So capital G from here, small g from other parent. Or this can fuse with this one. So, but the result is same, capital G, small g, capital G, small g. Let's see what happens if other gamete fuses. This gamete can fuse with this one, capital G, small g, or this can fuse with this one, capital G, small g. We can see the genotype of all the plants of F1 generation are same, capital G, small g, capital G, small g, capital G, small g, capital G, small g. Genotype is same, so phenotype is also same. All are heterozygous, and the result will be green pod plants. Okay, green pods. Now for F2 generation we have to self cross, capital G, small g, and this, both the parents are crossed. These are the parents. Formation of gametes, separate, capital G, small g. Here same, capital G, small g. Now F2 generation. This gamete, if fuses with this one, the result will be capital G and capital G. If this gamete fuses with the other gamete of water, capital G, small g. What if this gamete is used? Capital G from this parent and small g from this parent. This is fused with this one, small g and small g. So we can see the 4 plants, capital G, capital G, capital G, small g, capital G, small g, and small g, small g. Genotype is different. This is homozygous dominating, so phenotype will be green color pods, this is heterozygous, but the result will be green color pod. This green color pod, but this is recessive, so the result will be yellow color pod. Okay, so phenotypic ratio of green pod and yellow pod plants: 1, 2, 3. 3 green and 1 yellow. Okay, so phenotypic ratio in this case also is 3:1. So whenever monozygous cross is done in F2, we get 3:1 ratio, phenotypic ratio. And if we say what about the genotypic ratio, we have to find the genotypic ratio. Then what will we do? Genotype, I'll do it here. Okay. Genotypic ratio. Okay, so whatever the genes we have got, type of genotype, we will write capital G, other is capital G, small g, and the last is small g. See again, capital G, capital G, small g, capital G, small g. Out of 4, we have 1. These two are same and this is different. So both capital, 1 plant, 1 capital, 1 small, 2 plants, and both small, 1 plant. So genotypic ratio is 1:2:1. Okay, जीनोटाइप में देखेंगे सो रेशो इज 1:2:1, बट फिनोटिपिक रेशो हमेशा क्या है 3:1. Okay, this was the in which condition. These are the examples of monohybrid cross. Okay, whenever we do monohybrid cross, what we do, we cross plants of opposite traits. One is homozygous dominating, other is homozygous recessive. In F1 we get all the plants with have same result, same genotype, same phenotype. When we self cross the F1 generation, in F2 we get phenotypically 2 type of plants, dominating and recessive, 3 dominating and 1 recessive. So phenotypic ratio is 3:1. But in case of genotype, we say homozygous dominating 1, heterozygous 2, and homozygous recessive 1. So genotypic ratio is genotypic homozygous dominating 1, heterozygous 2, and homozygous recessive 1. So genotypic ratio is 1:2:1, but phenotypic ratio is 3:1. Okay, this was monohybrid cross, and on the basis of monohybrid cross, Mendel gave 2 laws of inheritance there were 3 laws of inheritance given by Mendel, out of which 2 are on the basis of monohybrid cross. First is the law of dominance, which is on the basis of result found in the F1 generation. In F1 always what we found, that heterozygous condition is there. The genotype, if we look, is heterozygous, but phenotype is always the dominating one. So we can say the dominating allele express itself, but recessive allele couldn't express itself in the heterozygous condition. This is the law of dominance. Second law is the law of segregation, which in F1, F2 we can see during gamete formation the alleles get separated and either of them can be fused with the gamete of the other parent. Okay, this is the law of segregation. Segregation means separation. Alleles are separated during gamete formation.